We'll now start discussing some of the operations that we can perform on data structures. Whenever we look at a particular data structure, there are certain operations that we want to take a look at. In fact, these are operations that are common among several different types of data structures. We have things such as adding an item to the data structure. We have removing an item or deleting an item from a data structure. We even have searching for an item in the data structure. So these types of operations are common among just about every data structure that's out there. So what we're going to do is we're going to start by looking at arrays, and we're going to see how much time we need to do each of these three operations. Let's start by looking at the operations for adding array elements. Now, when we talk about adding array elements, we are meaning adding new elements into the array, but the problem is the array is a fixed size. So how do we actually accomplish this? How do we add more elements to it? What we're going to do is we're going to designate a maximum size of the array. So that way we can say, all right, if the array is initially empty, we can put some elements in there, but it can only go up to this maximum size. And the way we're going to do this is we're going to have a variable keep track of the number of elements. So let me give you an example here. Let's say we have the following code. So we have this max size variable, which we say is 100. The second line is going to create an array of integers, and we're saying that this array is of size 100, but then we have a second variable that's going to keep track of how many items we currently have in the array. So here we have a size which is 0. So we'll use this value to actually say how many items we have in the array. So if we want to add something, we just check, does adding an element exceed the maximum size? And if not, then we can go ahead and add that element to our array. Now we're going to talk about three different ways we can go about adding an element to an array. So one option is that we would just add it to the end of the array. Another option is that we can add the element at the very beginning of the array. And then our third option is we can add an element somewhere in between. We'll start by looking at how we would add an element at the end of the array. And this is actually the easiest of the three different ways of adding array elements, because it's kind of convenient that our size variable actually tells us the index of the next available spot. Because remember, it tells us the number of elements in the array, so the last index of the currently used element would be the size minus 1. So we can just use that particular value of size in order to decide where we want to add something. So all we got to do is just assign our value to that element, so the array element at size, and then we just increment size by 1. The other thing we have to do is make sure that our array isn't full, because as I mentioned earlier, if it exceeds the bounds, we can't really add the array element. Let's take a look at the code for inserting an element at the end of an array. So here we have a method which we call add@end, and we pass the array, we pass our size variable, and the item that we want to add to the array. So we first need to do a comparison right here, right there, to make sure that the size is not exceeding the length. Because if it's equal to the length, then that means we're already at the end of the array. We can't add anything else to it. But if this is not the case, then we can assume that the size is less than the length. Then all we have to do is just assign our item to spot a size, and then we just increment the size by 1. And that's it. That's all we have to do here. So here we only have to do a single comparison, and then if that's true, we would do 2 more constant time operations. So inserting at the end actually ends up taking O of 1 time, or constant time. Now what about adding an element at the beginning of the array? Well, we're going to have to make some room at the beginning. I can't just put it like right in front of the first element. There isn't a spot for it in the array. So we're going to have to move that element over one place. In fact, we're going to have to move all of the other elements over by one place. And the way we do that is, well, I can't just take the first item and put it into the second item, because then I lose the second item. So when we move all these array elements, we have to do it in reverse order. We have to take the last item in the array and move it over one spot, then the second to last item and move it over to the next spot, and all the way down to the first item, so then we can move it to the second spot. Here's some code that will allow us to add an item at the beginning of the array. So we're still going to pass the array, the current size of the array, and the item we want to add. we're still going to compare the size with the length to make sure that we can actually add an item to the array. And then this for loop that we have right here will take care of shoving all the items over one place. So notice that in here we start with I being our size. So i's are the element that we're going to be moving stuff to. So we start at size, and then we're going to take the previous element and put it in there. So here we're going to put the last element into a size. That's perfectly fine because there's initially nothing in a size. So we're moving it over there, and then we take the second to last item and we put it into I minus 1 technically, and then we just keep going until we get all the way to the end of the array. So notice that here I is going to end up coming down all the way to 1. So we're going to assign A1 to, we're going to store A0 into A1, I should say. So we're going to move everything over by one spot. And then the next line, this A0 equals item right here, is the actual insertion. So now we're going to add the item to the beginning because there is a spot in A0. And then, of course, we need to increment the value of our size variable because we have added something to the array. So how much time does this actually take? Well, the body of our loop that we had to move everything, that takes constant time because we're just assigning one array element to another array element. Now, what about the number of iterations? Well, that depends on the number of elements in the array. If we have a small number of elements in the array, then it doesn't take very long. If we have a large number of elements, it's going to take a lot longer to move those elements. So we're just going to say n is the size of the array. We're not going to use the maximum size of the array as our n. We're going to use n as the current size. So what that means is we have to move each element of the array. So that means this whole thing is going to take O of n time to complete. Now, what about adding an element at a specific spot? So we're saying that we want to insert at a specific index in our array. So this is actually pretty similar to the insert element at method for the vector class, where we can choose exactly where we want to insert an element in our structure here. Well, we can actually use the same approach that we did for inserting an element at the beginning of the array. The only difference now is instead of shoving all the elements until we get to the beginning of the array, we're going to shove elements until we get to the exact spot where we want to add that item. So we don't necessarily have to shove all the elements. We might have to, but we can stop as soon as we get to the element where we want to insert our new item at. Here is our code for inserting an element at a specific index. And from a high-level perspective, this doesn't look too different from inserting at the beginning. We still have to check to make sure that the size is not the same as the maximum size of the array. We still have a for loop where we're going to be shoving elements where we start at size and then we go all the way to our index instead of 0. We do our array assignments and then we add our item and increase our size. There are just a couple of little differences that I want to highlight. So the first thing is in our heading. So we add a parameter that tells us exactly which index we want to add our item in. Since it could be the beginning. If we wanted this to insert the beginning, we would just set the index here to be 0. But here we have some index that tells us where we want to add the item. And then the next difference is in our for loop, where our condition is no longer checking that I is greater than 0. We're checking to make sure that I is greater than index, because index is where we want to add it. So as long as this is true, we need to keep moving elements over. And then the last difference is when we actually insert the item, because instead of inserting it at a 0, we want it at a index. So these are the only differences between this method and the insert at beginning method. So what's the running time of this approach? Well, the only difference between this insertion method and inserting at the beginning is just the number of iterations of the for loop. So I mean, it could be all the elements, but it may not be. Well, remember, when we're analyzing an algorithm, we have to consider the worst case scenario. And in this case, the worst case would be that the index is at 0, which means we have to move all of the current elements of the array before we can add the new item. And what that means is, since we're saying that there are n items in the array, that the running time for this is going to be O of n.